Alright, here we go. Day 2, 100 days of Python, 100 days of code doing Python.
Hey guys, welcome back to day 2 of 100 Days of Code. In today's lessons, you're going to be learning about data types, numbers, operations, type conversion, f-strings, and a whole lot more. And by the end of today, you will have learned enough to build a tip calculator. So it looks a bit like this. It says, welcome to the tip calculator. It asks you for the total bill that you need to pay. So let's say it came to $124.54. We hit enter, and then it asks you what percentage tip would you like to give. So let's say we give a 12% tip. And it asks you finally, how many people do you want to split the bill between? So let's say there's 5 of us having the meal. Now it's going to calculate what each person should pay, taking into account all of these pieces of information that you've put in. So I know that I'm pretty bad at maths, especially when it comes to splitting bills, and I'm normally the person who just says, yeah, just tell me what I need to pay so I don't have to calculate it. It's like the bad at math tax that I pay. But in order to build this, you're going to need to learn some new skills, including working with numbers, converting data types from one type to another, and a whole lot more. So if you feel like you can tackle this no problems, then feel free to skip today's lessons. But I bet that there'll be loads of stuff that you'll come across in the upcoming lessons and coding exercises that's really going to make you a better developer. So once you're ready to get started, head over to the next lesson and let's start coding. Yesterday, you saw that we could use the len function to get the number of characters in a string. So, for example, when I write len hello and I print this out, we end up with 5. There's 5 characters in the string hello. Now, here's a question. What happens if instead of counting the number of characters in a string, what if I put in a number instead? And I wanted to know how many digits are in this number. Now, if I go ahead and run this code, you'll see that it actually crashes. I get a whole bunch of red text and it tells me that there is a type error and something about the type int. So what is all of this about? Well, in order to understand it, we first have to learn about data types. Now, on day 1, we already explored this data type called strings. Now, you're probably not going to be surprised to learn that there's a whole lot more other data types out there. And today, we're going to explore some of the most important and some of the most basic data types, such as strings, integers, floats, and booleans. And we'll explore each of these in detail. So let's take a look at some of the data types. So we already learned about strings, right? And we know that this is just a string of characters. So the word hello is comprised of these 5 characters strung together. And we always know that strings, when we create them, we have to create them with these double quotes around. Now, because this is a string of characters, we can actually pull out each character individually. So we could, for example, instead of just writing hello, we can add some square brackets. So take a look on your keyboard and see where those are. And inside the square brackets, we can put the index or the position of the character that we want. So for example, if I wanted to have the first character out of this word hello, I would put 0 right here. And if I go ahead and print what this actually will give me, you'll see that you get capital H because that is the first character of this string. And it's really important to remember that programmers always start counting from 0 because we work with binary, zeros and ones. So whenever you want to get hold of the first character or the first of anything, it always is at 0. So this method of pulling out a particular element from a string is called subscripting. And the number in between the square brackets determines which character you're going to pull out. and it just goes up from 0 to 1 to 2 and so on and so forth. So whenever you get a result that's just off by 1, then remember to check whether if you've started counting from 0 or if you started counting from 1. Now you can of course extend this and get hold of the last character. So pause the video and see if you can change the code so that O gets printed out here. All right, so this is as simple as simply counting from 0, 1, 2, 3, 4. So if we change this to 4 and we run our code, then you'll see that O gets printed instead of the H. Now there's also a secret trick that not many people know, even seasoned Python developers. And it's the fact that you can actually use negative indices. So instead of specifying the position as a positive number, you can also use a negative number. And -1 means get hold of the last character in the string. So we can go ahead and run this and you can see it's also O. And we can start counting backwards as well, starting from the end going to the beginning. So that's just a quick tip. So by using these square brackets and putting a number inside, we're able to dissect our string and pull out individual characters as and when we need it. And this will come in really handy in a lot of the programs that you'll write in the future. Now, it's important to remember though that just because I can write a number like 1, 2, 3, as long as it's capped inside these double quotes, then this is not treated as a number by the computer. It's treated just as any other piece of text. You can't, for example, say, what is 1, 2, 3 plus 3, 4, 5? If I try to print this, what do you think will happen? Do you think it will give me 1, 2, 3 plus 3, 4, 5 in the traditional sense, like calculating it? Or do you think it'll do something else? All right, let's hit run. And we get 1, 2, 3, 3, 4, 5. So it's basically just concatenated these two strings together, just as we have done with other strings like hello and world, right? Because it sees the data type of these two pieces of data as strings, when we use the plus sign, it will actually just concatenate these two things instead of doing a mathematical operation. Now, if we want to do that, then we actually have to declare our number as a number data type. So one of the most common that you'll see is called an integer. So this is programming lingo for just whole numbers, numbers without any decimal places. And in order to create an integer or declare an integer data type, all you have to do is just write the number without anything else. So now, if I just write the numbers 1, 2, 3 plus 3, 4, 5, and then I go ahead and print this, then you'll see that we actually get 4, 6, 8. So it's actually being calculated because I've got actual numbers instead of strings. Just as we have some useful things that we can do with strings, there's some really handy things that you can do with integers. Commonly, when we write large numbers, at least in the UK or in the US, we like to put commas in between the thousands. So when we think of large numbers with these commas in between to split it into an easier to understand number, in Python, we can replace those commas simply with underscores, and it will be interpreted by the computer as if you had written this. So the computer actually removes those underscores and ignores it. The benefit is just for us humans to be able to visualize it more easily. So I mentioned that all whole numbers, no matter if they're positive or negative, are called integers in programming. So what do you call it when you actually have decimal places? Well, they're called a float. And this is short for a floating point number. So for example, if you had the numbers of pi, you have 3.14159. And this, because it has a decimal place, is now a float data type. So if you think of the decimal point as being able to float around the number because it could occur at any point, then you've got yourself a floating point number. Now the final data type is something called a Boolean. And this is very simple. It only has two possible values, true or false. Now note how these values always begin with a capital T or a capital F, and they don't have any quotation marks around them or anything. So this is actually a data type which is going to be used a lot in your programs to test if something is true or if something is false, and for your program to respond accordingly. So we're going to be using this a lot more in the future. Now that you've seen a lot of the basic data types, strings, integers, floats, and Boolean, I want you to head over to the next lesson where I've got a quiz for you to see if you've made this knowledge your own. So head over to the quiz and give it a go.
Incorrect. That's correct. That is correct. That is correct. This is not correct. Because the quotations around false. Data type, the mystery variable. That is because of the decimal, a float. Now, our computer, if I give you the following code, what will you print out? Abbey Road. Fourth is 0, 1, 2, 3, 4. Y plus. So we're going to concatenate street name 7, 0, 1, 2, 3, 4, 5, 6, 7, Y, 0. Okay. There we go.
Previously, we saw how the len function gives us a type error when we give it a number instead of a string. So let's talk a little bit more about data types and functions. And the way I think about functions is kind of like some sort of fancy machine that you might see in a factory, right? So in this case, we've got some sort of machine that's going to take potatoes into chips. And we don't really care how it does it, but it's probably going to have to peel the potatoes, wash the potatoes, cut it up, fry it, and then finally return it to us as an output in the form of fries. And if this is the first time that you're watching one of my tutorials, this is probably a health warning. I talk about food a lot. So be prepared if you haven't eaten. Now, let's say that we took the same machine that normally processes potatoes and we decide to give it a rock. And we just pass this through the function. Then we're going to get an error, right? This is basically what happened here. This length function doesn't like working with integers. And by forcing this through, we end up with an error and our code breaks. And it gives us this thing, a type error. Now, if we hover over this yellow warning, we also get the explanation here. Expected type, something called sized, and got int or an integer instead. So this is already pretty clear where our mistake is, even before we hit run. And the other helpful thing is when you hover over any function in PyCharm, it gives you the definition of it. And in between the brackets, you can see the data type that that function expects. So the length function expects a data type with something that's called sized. And we can actually click on this link to see the documentation on docs.python.org, which is the official Python documentation. Now, I know previously I told you to try using something like W3 Schools or using Stack Overflow, and the reason is because the documentation from the official Python organization is very, very short. So sometimes it can be enough, But very often I find that it's helpful to find another source to back up this very, very brief explanation. But in our case, in this situation, it does help us. For example, it tells us that len will return the length, which is the number of items of an object. And the argument, which is what you put in between the brackets, may be a sequence, such as a string, byte, tuple, list, or range, or a collection, such as a dictionary, set, or frozen set. Don't worry about these other data types that we haven't come across yet. We're going to come across them in due time, and we're going to be learning all about them. But for now, you already see one that you recognize, which is string. So it can take string, but nowhere in this list does it say it can take an integer or any other number data type. So as the first pause exercise, I want you to fix this len function so that we actually give it a data type that it recognizes, and we fix this type error so that when we run it, it works as expected. And you can put anything in there as long as it gets rid of the warnings and errors. Pause the video now.
Just put quotation marks. Or even, I know a little bit. Alright, I know that this will work. So the issue is that len does not print. So that, yes. 1, 2, 3, 4, 5. Correct length.
All right, this should be relatively easy. We can change this to any string, which we already know is a data type that this function can accept. So we can simply change it to hello or whichever string you can think of. And now when we hit run, all our errors and warnings should now go away. If you see something like pep8 blank line at end of file and it bothers you, don't worry about it too much, but it's basically saying that in an ideal situation, a Python file should only have one blank line at the very bottom. So if I hit run again, that will clear up that warning. For everybody out there who has a little bit of OCD like me, this can be a lifesaver. So now that we've seen that in Python, each function expects to work with a specific set of data types. So there's only certain data types that can go into the parentheses of a particular function. Now, here comes the question. Well, how would we know what data type a particular piece of data has? So how would we know what is the data type of hello? Well, it's very easy to visually see it because it has the double quotes around it, and anything with double quotes around it, even if it's a number, is in fact a string. But there is also one function in Python that allows us to check the data type of any piece of data or variable. So all we need to do is to use the keyword type, and then in between the parentheses, we can put in any piece of data. It can accept any data type, and then it will give us in return the data type. But as always, in order to see it, we have to wrap this inside a set of parentheses and use the print statement to put this into the output area. So let's run that, and you can see it tells us that this is something called a class string. So this is basically saying it checked the data type of this piece of data we gave it, and it told us that it's actually a string, which is what we expected as well. So we can do this with various different data types. Let's check it with a number. Well, in this case, we gave it a whole number, so no decimal places, and it told us it's an integer. We could do this with floats, with booleans, and it will always very, very helpfully tell us what is the data type. And this is something called type checking. So now it's time for another quick pause check to make sure you understood what's going on. I want you to write out 4 lines of code to print out the 4 different data types that we have already learnt about. So it's going to be the string, the integer, the float, and the boolean. And we want all 4 of these printed out in 4 lines in the output area using what you've learned and the correct data type to put in inside the parentheses for the type check. So pause the video now and give this a go.
Alright, so to get a, let's copy all of this. Alright, class string, we just need something within quotation marks. Alright, now we need an integer, 1, 2, 3, 4, 5. A float, 1, 2, 3, 4, dot 5. And a boolean, true. Alright, and string, integer, float, boolean, cool.
All right, so we've got already the integer type. So let's put the very simple string. So we all know that this is a string because it's enclosed in a set of double quotes. But what if I wanted to turn it into an integer? Well, I can use one of the built-in functions called int, and I can convert this into a number. So whereas previously we saw that if we tried to print the string 123 plus 456, then we would end up with 123456. And because both of these pieces of data are string data types, the plus sign does concatenation instead of maths and adding these two together. But now that we've converted this 123 into an integer, you can see that if we replace this string with this typecasted integer, and we could do the same for 456, now if I hit run, you'll see that it actually treats them as numbers and adds them together. So this is the power of type conversion. Now, one of the dangerous things about this is, of course, sometimes you can't convert things into a different data type. For example, if I tried to convert ABC into a number, well, that doesn't really make sense. If I gave that to you, what would ABC be as a number? I don't know. So if we run this, you can see we get something called a value error. So I hope you're collecting these errors in a notebook somewhere, because we're coming across lots of them, and you will come across more in your lifetime as a Python developer. So this is saying that there is an invalid literal for the int, which is ABC. And so it doesn't really make sense to convert this into a number, is what it's trying to tell you. So you have to be really careful when you're doing type conversions, because sometimes you can end up with errors and sometimes you can just simply lose data. But we can use this method to convert things into all of the four major primitive types that we've learned about. So we can convert to an integer, we can convert into a float, we can convert into a string, and we can even convert into a bool. So to check that you've understood how to convert between different data types and why we get different type errors, I have a final pause challenge for you, which is to make this line of code run without errors. So I want you to go ahead and copy this line of code, paste it into your code file, and try to hit run. Now go ahead and enter a name triggered by this input, and then you will see that you get a type error. So read through the type error, see if you can understand what it's trying to tell you, and fix this code so that it does what you expect it to do, which is to print out the number of letters in the name that the user submits into the input. Pause the video, give this a go.
Needs to be typecast as a string to be able to concatenate with another string. So pretty this up. Bada boom, bada bang.
All right, so in order to break this problem down, let's use some variables to simplify things and make it easier to read. Let's take this second part of this print statement and let's take it out into separate variables. So we know that we can get the name of the user by using this input function. And I'm making these variable names extra wordy just so that when you read it, it makes a little bit more sense. And I'm actually going to delete the rest of this as well, just to make everything easy to read. So next we need the length of name. And this is done by using the len function, and we pass in the name of the user that we got from line 1. So now finally, what we have here is the length of the name, which we want to tag to the end of this print statement. Now, what is this error trying to tell us? It's saying you can only concatenate string to a string, not an integer, which is what it sees in this line of code. So where is the integer? Well, we know that when we calculate the length of something, it gives us a number, it gives us a whole number. So this is probably an integer. Well, we can verify this by using a type check, right? We can print the first part of this concatenation and we can put it inside a type function to check what is the data type of this first part. And then we can also check the data type of the second part, which is now called length of name. So let's comment this out. Let's go ahead and run this code, enter a name, and you can see the first one is a string and the second one is an integer. So this is a type string and this is a type int. So now it makes sense that when we're printing, we can't simply concatenate a string to a number. It doesn't know how to do that. So how can we convert this length of name into the same data type as this first part, which is a string? Well, you learned how to do that already. All we need to do is to wrap this inside a set of parentheses, which is the string type conversion. And so now we have this part, which is now a string, and then we add it to another string. And now if I run this code again, then you'll see that it works without any issues. Number of letters in your name, 6, printed out. So hopefully this makes sense to you and you'll be able to understand in the future how to do type conversions and how to understand when you have different type errors, what has gone wrong.
All right.
In the previous lesson, we saw how we could use the plus sign either to concatenate strings together or as a mathematical operation where we add 2 integers or 2 floats, basically 2 numbers together. In this lesson, I want to show you some of the other mathematical operators that you have access to, in addition to adding. The next obvious one is subtraction. So 7 minus 3, you would just use the minus sign. But then when you get to multiplication, it's a little bit weird. Instead of using the x or some sort of time symbol, you actually use the asterisk. So you would say something like 3 asterisk 2, and that would be 3 times 2. Now the final one is division, and that's done using the forward slash. So 6 divided by 3, and when that prints out, it'll give you 2. Now one thing to notice here is that whenever you're dividing things, you actually always end up with a floating point number. So you can see even though 6 divides into 3 cleanly, we're still getting 2.0. And in fact, if I put a type check around this division, you'll see that it'll print float instead of integer. And this is just the default Python behavior. It's something called implicit typecasting. because Python is implicitly converting the result here into a floating point number. Now, sometimes you might not want that. So there is an other Python division operator that might be worth knowing about. And it's simply done with 2 forward slashes. So now when I run it, you can see what comes out is actually an integer. And I can do a type check just to confirm that as well. Instead of float, it's coming out as an integer. But you have to be very careful with this second type of division operator, because what it's doing behind the scenes is it's actually doing this step first, and then it's simply just removing all of the decimal places. So what if instead of 6 divided by 3, which we know divides cleanly into 2, what if we divided 5 by 3? What is the result of that? That's 1.6 recurring. So if I change this into 5 divided by 3 using the double forward slash, you'll see that it just gives me 1, and it wipes out all the rest of the numbers in this integer conversion, which can be quite dangerous if you're working with scientific numbers. But it can be useful when you know that you want an end result that has no decimal places. Now, the last one that's really useful is 2 asterisk signs. And this gives you access to the exponent, or when you want to raise a number to a power. So for example, if you wanted to get hold of 2 to the power of 2, then you would write it like this. And 2 to the power of 2 is, of course, basically just 2 times 2, which is going to be equal to 4. Now, if I change this to 2 to the power of 3, then that's going to be 2 times 2 times 2. So that should be 8, and so on and so forth. Having the exponent being built into the language is one of the reasons why Python is really loved by a lot of data scientists and mathematicians, because it's really optimized towards manipulating and handling numbers. Now, one of the things that you have to be careful about when you are doing these mathematical operations is when you have more than one operation on the same line of code, then there's a certain level of priority. So some of these operations like division or multiplication are going to be first class, whereas other ones are going to be more economy, like the plus and minus. And the rule that you might have remembered from high school is something called PEMDAS. It basically states the order of priority is parentheses, exponents, multiplication, division, addition, and subtraction. So the things that happen first are the things inside brackets, then it's our exponents, then it's our multiplication and division, and finally the lowest priority is our addition and subtraction. Now, it's a little bit deceiving because of this order. It makes it seem like as if multiplication happens before division, but actually they are equally important. And when it actually comes to your calculations, the calculation that's most to the left is the one that will be prioritized between multiplication and division. So let me give you a real life example to make this more clear. Let's say we had a line of code where we wanted to multiply 3 by 3 plus 3 divided by 3 minus 3. If I was to execute this entire line of code and print it out into the console, here's the time where you play computer again and guess, using what you've learned here, what exactly will be printed. Because you will get a number printed. It will calculate this entire line of code for you, but the order matters. Is it going to first add 3 to 3, then multiply the result by 3? Or is it first going to divide 3 by 3 and then add 3 to it? What is the order? And I want you to really pause the video and have a little play with it on pen and paper before you come back and we'll show you the result.
10 minus 3 equals 7.
Using our rule PEMDAS, we can see the first thing that happens is what's in the parentheses, so that doesn't matter. The next thing are exponents. We don't actually have an exponent here. We don't have 2 to the power of 3 or something to the power of anything, so we can ignore that as well. So the next level is the multiplication and division. And as I mentioned, they are of equal importance. So this 3 times 3 and 3 divide 3 are both equally important, but the calculation goes from left to right. So the first thing we see is actually the multiplication. So if it helps you, you might want to add LR to the end of this mnemonic. So it becomes PEMDASLR, or at least that's the way I would think about it. So even if this was division and this was multiplication, this calculation will always get executed first. Coming back to the question I asked you, what do you think this number would be? Let's go ahead and comment out all the other code and run this line of code, and it will give us 7. Now, if math is not your strong point, don't worry, it's not mine either, and you're the sort of person who would prefer to see it visualized, then I recommend, again, putting this line of code in Thonny, and then go ahead and clicking on the debugging symbol, and then just step into, so press F7 or this button multiple times, and you'll see it evaluate this line of code step by step. So first it looks at the entire thing, and then it goes from left to right. And the first calculation is 3 times 3, and that is the one that's going to execute first, and it becomes 9. Next, it's going to look along this line of code and see that the next most important thing is this division here, 3 divided by 3. So it's going to carry out that next, and that becomes 1. So now 9 plus 1 is going to be the next thing because it's the most to the left, and then it becomes 10 minus 3, and we finally get the result of 7. So now here's another challenge for you. How can you change this code so that instead of getting 7, we get 3? How can you change this line of code given what you know about PEMDASLR? See if you can figure it out. Pause the video.
Change it so that it equates to 3. I think if we that would make this 6. That would make this 18. 18 divided by 3 would make this 6.0 minus 3 would come to 3.0, which is what we're looking for.
Now. Alright, so this will involve a little bit of trial and error, and the most important tool we have access to us is the parentheses or the brackets. This means that we can actually isolate bits of our code which normally have very low priority and turn them into higher priority operations. If we added a set of parentheses around our 3 plus 3, then out of all of these calculations, this particular one suddenly becomes the highest priority and it will happen first. So if I change what I've got in Thonny to our new version and go ahead and debug through it, the very first calculation it's going to perform is this 3 plus 3 inside the brackets. And we end up with 6. So then it's going to go again from left to right, prioritizing multiplication and division. So then it's 3 times 6 is 18. 18 divided by 3 is 6. 6 minus 3 is 3. Just by isolating certain calculations, you can elevate it to right at the top of the priority list, and you will be able to perform the calculations that you need. Now that you've learned a lot about calculations and performing mathematical operations using Python, I've got another code challenge for you. So head over to the next lesson and you'll be able to discover it there.
Okay. Measure used in medicine to see if someone is underweight or overweight. is equal to the person's weight divided by height squared. Needs an exponent of 2. 30.85. Right.
In the previous challenge, you saw that when we calculated the BMI and we printed out this large number divided by another number, usually there is a large number of digits after the decimal place. Now, this is not really an ideal way to output some number to the user. We'd really like to be able to round it to the nearest whole number or to a specified number of digits. So how do we do this? Well, you've already seen that we can convert any number into an integer. So instead of simply just printing the original BMI, we can convert it first into an integer and then we try printing it. You can see what this does is it floors the number. And this is a programming term for basically just removing all of the remaining decimal places, flooring it to the lowest whole number. Now, that's not quite what we want. We want to use the round function, which performs the rounding in the traditional mathematical sense, where when it's 0.5, it rounds up to the next whole number, and when it's below that, it rounds up to the lower whole number. So let's go ahead and print using the round function and round our BMI instead. See what all three of them print. So this is our original value, 3.85, and when we simply chop off the end, we have a whole number, 30, and this is called flooring, whereas rounding will round up or down one whole number depending on the first decimal place. So in this case, it becomes 31. So this depends on, of course, whether if it is 3.9 will round into 4, whereas 3.3 will round into 3. So it's a really, really handy function when we're working with numbers in Python. Now, you can go even one step further. Instead of just rounding the number, notice that it actually takes two inputs. So when I typed out round, and you can see the auto-suggest showing me the function that it thinks I'm trying to get hold of. It takes two inputs. One is the number you want to round, and the second one is the number of digits you want to round it to, which is kind of helpful because what if we wanted to take our BMI and we wanted to round it to 2 decimal places? Well, then we would write BMI as the number that will be inserted here from this variable, and then we just simply type 2. And now when I hit run, you'll see that this time, instead of simply rounding it to a whole number, it rounds it to a floating point number with 2 decimal places of accuracy. So that can be really helpful if you're working with money, for example, and you're doing Pythonic calculations, working with currencies or conversions. So Python is just generally really, really number friendly. Now, while we're working with numbers in Python, another really handy operator is called the assignment operator. So we have various different ones depending on which mathematical operation you want to do. But essentially, what this allows us to do is to accumulate the results of our calculations. Now, very often when you're writing code, say, for example, if you're keeping track of the user's score, so you could have score equals 0 to begin with, and every single time in your code, say a user scores a point, then you can get hold of this score variable again, and instead of saying score now equals the previous value of score plus 1, you can simply use this shorthand, plus equals. So plus equals 1. And now when we print score, you'll see that it's actually equal to 1. So instead of using plus equals, you can use minus equals, which just takes the previous version of score and removes 1 from it, multiply equals, and divide equals. So this is really handy when you have to manipulate a value based on its previous value, which you'll have to do a lot in programming. Now, the final thing I want to show you is something called f-strings. And this makes it really easy to mix strings and different data types. So far, up to this point, if we wanted to print something like your score is, and then we wanted to print the score, we have to write plus, but of course, because these are different data types, this is a string and this is an integer, we get a type error. So we've had to convert this into a string before it will actually successfully print when both the data types match. Now, this is quite painful, and understandably, a lot of programmers will need some slightly more convenient way of incorporating things that have different data types. Let's say the score is equal to 0, let's say their height is equal to 1.8, and is winning is equal to true. So here we've got a integer, a float, and a boolean, and we want to mix it all in to a sentence that is a string and get it printed out. So instead of having to convert all of these and use a whole bunch of plus signs, and then you have to convert everything into a string, it's really, really painful, right? So what we can do instead is use something in Python known as an f-string. And what an f-string allows us to do is in front of a string like this one, we type the character f. And it's really important that it goes in front of the double quotes or single quotes if you want to write your strings like this. But I like to use double quotes, and a lot of other Python programmers do too. So essentially you're adding just the character f in front of the string, and now this is an f string, and you can start adding various values into this string. So for example, if I wanted to write your score is equal to this variable score, then I can put that variable inside a set of curly braces like this. And now when I print my string, this one right here, you'll see that it says your score is 0, and it does all of the converting and all of the stuff behind the scenes, and you don't have to worry about any of this. So if I want to continue along, I could say your score is this, your height is, add in the height, and then you are winning is, then let's add that final Boolean value and get it to run. You can see that our entire string now prints out your score is 0, your height is 1.8, you are winning is true. So all of these different data types got combined into a string by using an f in front of the string, and then using these curly braces to place our variables into this string. By using f-strings, you cut down on a lot of the manual labor of inserting different data types into a string. And this is going to come in really handy just about on the next lesson, where I've got a coding challenge for you. Head over there and complete the challenge.
Alright, PEMDAS. This will be 2. This equates to 2, so 6 plus 2, 8. Minus 2 is 6 because of the division. It is 6.0. Data type of the result of variable A. Because of the division, even if they start out as integers, they will end up as floats. So these lines of code will give you an error. Alright. good to me. This is our problem child because this is an integer. You cannot concatenate strings with integer. Cool.
Hey guys, welcome to the final project of today.
It's that time
And
already.
in this final project, we're going to be building a tip calculator. So the final output is going to look like this. It's going to print welcome to the tip calculator, and it's going to ask you for an input for how much the total bill came to. Let's say that we and a couple of friends went out for lunch and it came to $124.56. And then it'll ask you what percentage tip would you like to give. So let's say we want to give a 12% tip. So we enter 12 and hit enter. And then finally it asks how many people are splitting this bill. Let's say there's 7 of us. And then hit enter. Finally, it's going to tell us that each person should pay about $19.93. Notice how the final bill, even though after all of these calculations, it's probably got more numbers after the decimal point, we only want 2 decimal places of accuracy, so it should be rounded to 2 decimal places. The second thing to remember is that these are percentages, and in order to calculate a percentage of something, you can multiply a number by the percentage number divided by 100. Let me show you this in a little bit more detail, because this project is not about testing your maths, it's about seeing how well you've understood the programming concepts. Let's say that we had a bill of $150. If we were to apply a 12% tip on top of that, then 12% is going to be equal to 12 divided by 100, which is equal to 0.12. Now the next step is we can multiply 150, the total bill, by 0.12, and this will give us what 12% of 150 is, which is 18. Now we of course have to add the tip onto the final bill, so it becomes 150 plus 18. So $150 with 12% tip is equal to $168. Now a shorthand way of doing all of this is simply multiplying 150 by 1.12. So the 1 is 150, and then it's 0.12 on top of that. So when we do this, it gives us pretty much the same number. Now, if during your testing and your coding you come across some sort of number that looks a little bit strange because you think 150 multiplied by 1.12 should actually equal 168 precisely. So what are all of these extra numbers at the end? Now, the short answer is you don't have to worry about it. It's simply related to how Python processes these floating point numbers. If you're really interested and you want to read about this, then I'll link to this page in the Python documentation where they tell you why this is happening. But be warned, it's pretty dense and it's pretty heavy. But the final conclusion is it's just the way that Python is approximating this number. So you don't actually have to worry about this. Now, once we've gotten to 168, the next step is to split it between 5 people. So 168 divided by 5 is equal to 33.6. Now, what we want to show the user is we want to show them the amount that they have to pay with 2 decimal places of accuracy. So we want to say something like 33.60 if this is the case, because that's normally how we represent numbers when it comes to money. So what I want you to do is to also be able to round any of these numbers to 2 decimal places. If you have successfully created this program, then it should work exactly as this example version would. And you'll be able to see the formatting where it actually tells you each person should pay this particular dollar amount, and it's rounded to 2 decimal places. And this is the amount after taking into consideration these 3 different inputs from the user. Have a play around with the final product and then have a think about how you would create this program step by step, and then try to achieve this result. This is going to test everything that you've learned so far, including f-strings, including complex mathematical operations, including PEMDAS and calculating numbers and the order in which mathematical operations are run by a computer, as well as everything you've learned in the previous lessons and previous days as well. I think this is going to be a lot of fun, and the end result is going to be kind of useful the next time that you need to split the bill between friends. So I'm going to let you pause the video and get on with it. And then once you're done, if you want to, head back over here and I'll walk through the solution with you. But I really recommend you giving it a good go before you come back. So pause the video now and I'll see you later.
Alright, let's get the visual formatting set up first. Okay, they already got that set up mostly, I think. Yeah, alright. So we have the bill, which is a float, because there will be, added on cents. Tip is an integer. Alright. Amount of people, integer. Cool. Alright, so we need a variable for total per person. And this will be a float. Needs to be rounded. It'll already be a float because of the bill. Or it should be. Alright. So we're going to take the tip trying to remember what the equation was. Well, actually, let's first do bill total, and that will be including the tip, and that will be bill times tip. Right, 12 divided by and then we want to do plus 1. So this was supposed to be right. That should be it. Let's test this out. Print bill bucks because we'll do a 20% tip because it doesn't matter here. Sorry. 20. Cool. Very nice. So that is the correct bill total. Total per person equals bill total divided by people. Right? Then each person should pay. Let's go ahead and round this. I want to say this is the syntax. Print. Let's try the F string. Each person should pay. Right, I think so. $100. 15. Let's just bring out the calculator. That should be 115 divided by 4. Cool.
Next line is going to be another input. Here I'm asking the user how much tip would you like to give and giving them some examples. And notice how in my examples I don't actually have the percentage sign here because I don't really want them to type the percent sign into this input, because if they do, when they say 12%, this is going to be really hard for me to turn the 12% into an actual number. So you could, in your input message, say something like, how much tip would you like to give? 10, 12, 15. Please don't add any percentage signs, just add the number or something like that. But again, once we've done this, it's not stored anywhere unless we add it into a variable. Now we've got a bill that stores the total bill as a float. And we've got a tip, which is going to be a whole number, 10, 12, or 15, right? So depending on what you think is best, you can either turn this into a float, or in my case, I'm probably going to convert it into an integer. So now we're on to the final step, which is how many people to split the bill between. So let's go ahead and create a variable called people, and I'm going to add an int wrapper around this input so that even in the very beginning we know that we have to convert the number of people into a whole number, because I've never had a meal with 3.5 people before. So the input is going to be how many people to split the bill, and at this point they should enter the number of people, which will turn into an integer stored inside this variable called people. So now that we've got all the data collected from the user, we're finally ready to do some maths. And we said that the way to work out the tip is by multiplying it by 1 point, and then the number after the decimal point is whatever percentage they decided to give. So it would be 1.1 if it was 10% and 1.15 if it was 15%. Let's go ahead and calculate the bill with tip. So remember how we said that before the tip percentage is equal to the whole number, 10, 12, or 15, divided by 100, which turns it into 0.1, 0.12, or 0.15. And then, once this calculation is done, we can multiply it by the bill. And then finally, we add that to the original bill. So let's go ahead and print this and just check to see that it looks sensible. So bill with tip is what we're going to print, and let's put some easy numbers in there.
I like the way I
Let's
did it
say that
more,
the
but
bill was $100 and the tip was 10%. So then the 10% of $100 is $10. So the bill with tip, that's what's going to be printed next, should be 110. So we can type anything in here because we're not using it. And you can see that this calculation, bill with tip, is 110, which is what we want. Now, there's a lot of other ways that you can express this. For example, you could say bill times 1 plus tip divided by 100. So this would actually give you the same result as well. But remember what we said previously about how Python is a little bit weird with floating point numbers. But essentially, this is still giving us the same result, which is 110. So you can choose whichever way you find most intuitive, and if you want, you can even split this up into several steps, right? We could say that tip as percent is equal to tip divided by 100, and then we can multiply the bill by the tip as a percent to get the total tip amount. And then finally, we can get the total bill by adding the bill to the total tip amount. Feel free to do this whichever way makes sense to you, but I'm going to leave it with as many steps as possible so that you can actually work through the logic if you got stuck on this maths. Now, the next thing we need to do is to divide the total bill by the number of people. So if we had 5 people, then we would divide it 5 ways, right? So let's call this bill per person, which is going to be equal to the total bill divided by the number of people. Now, at this stage, this bill per person is a floating point number, so it could have many, many digits after the decimal point. If we want to round this to 2 decimal places, then you might remember from some of the lessons today, we have access to a function called round. And here we can add the number that we want to round, which is the bill per person. And then after a comma, we can specify how precise, how many numbers or how many decimal places do we want to round this bill to. And in our case, it's 2 decimal places. So now this is the final amount, which I'll call final amount, which is the bill per person rounded to 2 decimal places. And we can now finally print this to the user and say each person should pay. And remember, you can either use string concatenation, which will require you to convert this number into a string again, or use the trick that we learned in the previous lessons where we can create an F string by adding F in front of the string and then using some curly braces to insert the final amount right here. And we can write the final amount dollars, or we can put a dollar sign in front and maybe a colon here. And now if we clear our console and run our code, then you'll see it work. So welcome to the tip calculator. What was the total bill? Let's make up some random number. What percentage tip? Let's say we're going to give 15, and then we're splitting it between 5 people. And it calculates everything, doing all of that maths. And finally, it rounds it to 2 decimal places, giving us the final amount each person should pay. How did you get on with this project? Did you manage to get it in one go without having to look at the solution? If you got stuck at any point, or if your code didn't work as you expected to, this is the time to go back to it, fix it, and make sure that you've understood everything that's been covered through this exercise. So I hope you had fun building this project and doing all of the coding exercises and learning about mathematical operations, f-strings, data types, type conversion, and all of the things that we did today. Have a rest, and I'll be back tomorrow teaching you about conditional statements and how we can get the program to do different things depending on certain conditions or certain parts of our code. So I bid you good night, and I'll see you tomorrow. Hey, you've completed day 2. So you haven't just done one lesson, you've actually done 2 now in a row, which is fantastic. And in fact, you are now above 50% of all the people who start something and never finish. But I know you. I know you're not one of those people. I know you're going to keep going and you're going to get this in the bag. So keep going, have a rest, have a good night's sleep, and I'll see you bright and early tomorrow morning.
All right, day 2 down. Day 3 tomorrow.
Hey guys,